In this problem, we're going to look at the question, which is the first problem from our in-class problem set on probability, where the question is as follows. Suppose you're given a bag containing n unbiased coins. You're told that n minus 1. Okay, so there's a slight typo on the question. I had one of these coins, but it should actually be n minus 1. So you're told that n minus 1 of these coins are normal with heads on one side and tails on the other, whereas one coin is a fake coin with heads on both the sides. Sure work for the following questions. So for the first one over here is suppose you reach into the bag, pick out a coin uniformly at random, and you flip it and you get a heads. So you take a coin out from a bag, and you don't see what the coin is. You don't see what kind of coin is this. You just take a coin out. You don't observe the coin. You flip it. The only thing that you observe is whether you get a heads or a tail. Okay, so when the experiment has been conducted, you see that you get a heads. Okay, so the probability, okay, you need to find some kind of a probability. But what you have observed here is that you have got some kind of a heads here. Okay, so this is something that has been observed here. Now, because you get a heads here, what is the conditional probability that the coin that you happen to choose from the bag is a fake coin? Okay, so what is the probability of you having actually a fake coin, given that you have observed a heads here? Okay, so this conditional probability is nothing but equal to, again, taking things right from the lecture, is the joint probability distribution of fake and heads happening together over the probability of heads. Now we also know that the joint probability distribution can also be written as the probability of you observing a heads, given that the coin was fake, times the probability of the coin actually being fake, divided by the probability of heads. So I've just rewritten the joint probability distribution as the conditional probability distribution of heads given fake times the probability of fake. Okay, so at this point, think of this. This is one of the things with the Bayesian theorem, that you have some kind of a notion. You have some kind of a notion about what the probability of fake is. Okay, this is something that you have some data. It could be a prior information, it could be something that you know from before, but you have some data that tells you that that you believe the probability of fake to be something. But then what happens is that you get some evidence. Okay, you collect some evidence. So this is the evidence over here. You collect some evidence, and based on the evidence, you go back to your belief. You go back to your belief to see, has your belief of the probability of fake has changed the moment you start collecting evidence. Okay, so this is a belief. You had some belief originally and at that point you had no evidence. So you thought the probability of fake is something, and the moment you collect some evidence over here, the probability of fake, given that evidence, changes. Okay, so in terms of a Bayesian network or Bayesian inference, this piece over here, this box over here is called the prior. Okay, I'm just putting some terminologies here. It's called the prior, and this entire piece over here is called the posterior. Okay, so the probability of the same thing that has changed after evidence has been collected. Anyways, we're going to work on the question now. So on the question, what is the probability of heads given the coin was fake? Well, if the coin was fake to begin with, the probability of you observing in heads is definitely going to be 1, because the fake coin has heads on both the sides of the coin. So this is going to be 1 over 1. Okay, that's the probability of heads over fake, times the probability of the coin being fake. Well, the coin being fake, you're told this is 1 over n. You know that one of the coins out of total of n coins is actually fake, divided by probability of you seeing a heads. Okay, so probability of heads here, that's something that we need to calculate. So just going to use a different color. So the probability of this piece heads is something that must be calculated. So let's just put it as it is for the time being. Okay, and this entire piece is going to be equal to the probability of fake given heads. Okay, so what is the probability of heads now? The probability of you observing and heads is actually equal to so if I were to a simple Venn diagram here. So here is my Venn diagram, and so in my universal space, it contains the results of all the it contains results of my experiments. What are all the possible results that can happen in this experiment? Well, I'm just taking a coin and I'm flipping it. So what I can observe from this is I can observe from my experiment that look, some of them will be heads and some of them will not be heads. That's the result that I'm going to observe here. My question here is, what is the probability of heads here? I want to see the probability of this entire piece happening. But what I also do know is that, look, some of these coins are fake and some of the coins are not fake here. So I'm going to label everything inside the blue circle. Everything inside the blue circle are those coins that are actually not fake. So everything outside the blue circle are those coins that are actually fake. Okay? So first thing, let's do this thing. To find the probability of heads, which is this entire piece of my rectangle, is going to be equal to the addition of this piece, everything inside here, okay, which is this yellow piece over here, and you're going to add it up. You're going to add it up with everything that is in brown here, which is all of this piece. Okay, so if you take the brown piece and you take the yellow piece and you add them up, that's going to give you the probability of heads. So the probability of heads here is nothing but equal to the yellow piece, and the yellow piece over here is the probability of not fake and heads, plus the piece in brown, and the piece in brown is the probability of fake, because everything outside blue circle is fake and heads. Okay, so if I look at my the first component here, probability of not fake and heads, well, not fake and heads is something I need to calculate, but at least this piece over here, probability of fake and heads, is something that is this piece over here in the numerator, which is also equal to this piece over here. Okay, so this is something that I already do have the data for, okay, which is 1 times 1 over n. Now the probability of not fake and heads, well, this piece is equal to, so this entire piece in green, okay, let me use pink here, this entire piece in pink here, this box in pink, is equal to the probability of heads given not fake times probability of not fake. Okay, what the probability of heads happening given that the coin is not fake? Well, that is exactly half. This is exactly half. What is the probability of the coin being not fake? The coin being not fake is n minus 1 over n. Okay, so you have all the data that you require for the pink piece, which is this piece over here. You have everything that you require for the blue piece. The blue piece is nothing but 1 times 1 over n, and you have everything in the numerator as well, which is 1 times 1 over n. So you have everything that you require to calculate the probability of fake given heads.